Hello, Gary. So let us move to lesson 5. Okay. I hope you are having an idea at this point. I hope you're taking notes and I hope you are sending me your questions. Okay. So now for lesson 5, we're going to focus on this is from September 2025. And so for this question here we have, so let's read the question together. They say the circuit diagram below shows 3 light bulbs, a voltmeter, a battery, and 2 ammeters of negligible resistance. L1, L2, and L3 are identical light bulbs, each with resistance R. Okay, so the light bulbs here are identical, meaning they are the same. Okay, they are the same, and they all have resistance R. Okay, and then we have 2 ammeters. There is A1, and then there is A2. Okay, a battery has an EMF of 26 volts and internal resistance of 0.6. 8.1 is asking, what is the function of the ammeter A1 in the circuit? So let us look at where ammeter A1 is placed here. So the current that passes there, so the current that passes, the current goes from a positive terminal here, and then it moves. Okay, so the current that passes through A1 is not yet divided. Okay, it's not yet divided. So now it will measure the total current. So the current that passes there is the total current. Okay? So the function of A1 here is what? Well, same say A1 measures, you can say it measures, or you can say it reads. It reads the total current. Total current of the circuit. That is the function of A1, because the current that passes there is not yet divided. So it will measure the total current of the circuit. Okay, now 8.2, what are they saying? 8.2, when both switches are closed, A1 reads 5 amperes. When both switches are closed, meaning S1 and S2, when both of them are closed, A1 reads 5 amperes. Okay, so what do we know at this point? Is that the current that goes here, so the current that goes through L1 and L2 will be 2 times smaller. So it will be half of the current that goes through L3, because the resistance for L1 and L2 will be 2 times greater than the resistance for L3. Okay, so we can imagine what? That this 5 amperes will be divided into 3 parts. Okay, and then what will happen here is that 2 parts will go this side for L through L3, and then one part will go through L2 and L3. Okay. Now, they say calculate the reading on ammeter A2. Okay. For ammeter A2, the ammeter A2 is the current that will pass through L3. So that current will be 2 times bigger than the current that goes through L1 and L2. Okay, because the resistance is 2 times bigger this side. So the current will be smaller. It will be half of the current that passes this side. Okay, so what we're saying here is that 2 out of 3 parts of the what? Of the total current, which is 5, will be equal to, so okay, this is 8.2 and this is 8.2.1. So we multiply here, we get 3.33 amperes. So this is the reading on A2. Okay. And then 8.2.2. They want value of R. Okay. The value of R. What can we find here? We can start by finding the total external resistance, isn't it? Before we find R. So we can, because we have everything else. So we can say EMF equals to I, and then we can say R plus R. And then they told us, they said the EMF is how much? It's 26. Then you have 5 here. So it's going to be, therefore, 26, sorry, equals to 5. And then into R plus, and then 0.6. Okay, 0.6. And then we can divide by 5. So then we have 26 over 5 equals to R plus 0.6. So it means, therefore, we divide by 5, we get so we're going to have R equals to 26 over 5, and then minus 0.6. Minus 0.6, that is going to be equal to 4.6. Use the calculator here. So this is 4.6 ohms. So this is the external resistance. This is the total external resistance, isn't it? But then what do we know? We know that this is a parallel connection, isn't it? This is a parallel connection. There are 2 resistors that side and 1 resistor the other side. So now what we're going to do here is we're going to say 1 over Rp equals to 1 over R1 plus R2, and then plus 1 over R3. So then it's going to be, because all the resistors are the same, so then it's going to be 1 over 4.6 equals to 1 over 2R plus 1 over R. Okay. And then we can find the LCD here. So then it's going to be 1 over 4.6 equals to, and then 2R, and then it's going to be 1 plus 2. Okay. And then what happens? Then we say therefore 1 over 4.6 equals to 3 over 2R. And then if we have to find R, we make R the subject here. We cross multiply. So R is going to be equal to 3 multiplied by 4.6 divided by 2 equals to. You use a calculator here, you get 6.9 ohms. That is the value of R. Okay. That is the value of R. Then 8.243, they want the voltmeter reading. The voltmeter reading, which in this case is going to be the V external. Okay, so the external voltage in this case, because the voltmeter reading will be here, and it will be the external voltage. So we have to use the external resistance and the current. Okay, so for 8.2.3, okay, let me do it here. Eight point 2.3 is going to be V external. It's going to be equal to I multiplied by R external. So then it's going to be equal to 5 multiplied by R external, which we found. Okay, we found here is 4.6. So you multiply by 4.6, and then you get 23 volts. And then 8.2.4, they say energy dissipated by the light bulb that is in series with ammeter A2 in 2 minutes. So the minutes here should be changed into seconds. Okay, so the equation for energy, okay, 8.2.4, the energy is going to be equal to power multiplied by time, and power is the same as, we can take V squared over R, and then we multiply that by time. So take the voltage, okay? The voltage that we have, which is 23. It's going to be 23 squared divided by R, which is we found here 6.9. Yes, 23 is from here, and then we use the R 6.9. Okay, 6.9, and then multiplied by 2 times 60. So we convert the minutes into seconds. And then so you use your calculator here, and then your answer is going to be in joules. Okay, so the answer here, it comes here. The unit for energy is joules. Okay, now let us go to they say switch S2 is now opened and S1 remains closed. So S2 is opened, S1 remains closed. S2 is opened here and S1 remains closed. So what would happen to the total resistance of the circuit? The total resistance would go up. Okay. Now they say, how will this change affect the value of the lost volts? Choose from increase, decrease, or remains the same. The lost volts, which is the V internal, is going to be affected by the current. Okay? So in this case, the current will be reduced because the resistance will go up. Okay, so the lost volts will decrease. Let me do it this side. Okay, just do it here. 8.3. 8.3. 8.3.1. So the lost volts will decrease. Okay, I don't say decreases. So it decreases. Decreases. And then 8.3.2, I think we're required to explain. We're required to explain why. So, yes, explain the answer to question 8.3.1. So, here we're going to say total circuit resistance increases. So that this, and then this means that what? Total circuit current will decrease. So it would decrease as a result of an increased resistance, okay? And then this means what? So the current, the relationship between V internal, which is the lost volts, is directly proportional to IT, the total current, okay? So this is lost volts over here. The two are directly proportional to each other. And then this is the total circuit current. and this is why. So this is the reason why it will decrease. The current will be reduced by an increased circuit resistance. Okay. So that was it for this question. Again, as always, leave your questions in the comments. Let us engage further. Okay. And leave your questions in the comments, and I hope that was helpful. Let me know if there's something else that you don't understand. Okay. I'll see you on the next one. Take care.